Howdy there, lovely human being. Um, you clicked on a video, a math video. So, you know, just making sure you know. I hope you're doing well. How about you update your notebook as a warm-up? Let's consolidate a little bit. We'll pause this video, write questions, write a summary, get a page ready. No problem for a warm-up today, but how about you update that notebook and then we'll get started. All right, we're cruising right along because we didn't do the whole warm-up part. What are the properties of parallelograms? So we were talking about triangles, right, for a while, and then we started talking about polygons for just a bit, just a minute. We talked about polygons in general, and now we're jumping right into a specific type of polygon, a quadrilateral, which is a four-sided shape. So we've gone from three-sided shapes to four-sided shapes. Now, we're not just going to talk about quadrilaterals, though. We're going to talk about a specific type of quadrilateral. And the reason why we're going to do that is because when we have this specific type of quadrilateral called a parallelogram, there's all kinds of cool things that we can know about it and all kinds of theorems involved in being able to solve problems around parallelograms. This is a four-parter, friends. This is Parallelogram Theorems Part 1. So parallelograms come packed with properties, and that's why it's going to take us about 4 lessons to unpack all of them. So first thing I want to talk about is what a parallelogram is. A parallelogram is a quadrilateral with 2 sets of opposing, how about this, with 2 sets of parallel sides. That's good. 2 sets of parallel sides. So when we're looking at a parallelogram, we don't know yet a ton about the sides and the angles, except the one thing that we do know is that there are 2 sets of parallel sides. Now, I almost said opposing parallel sides, but then I thought, well, okay, so is this side of this parallelogram really going to be parallel to that one? And so that's why I thought, well, maybe it just comes as just a matter of, you know, it would be silly if that were true. So when we say that we have 2 sets of parallel sides, there's one set right there. And there's another set. And this is how we know that we have a parallelogram. All 3 of the figures you see are different types of parallelograms. I'm going to go ahead and put the markings on them. That's what these little arrows mean, that these sides are parallel. Let's do this one as well. Oops. Is that going to let me draw? No, it's not. Oh, well, I'll get to that one in a second. So what we're going to do is we're going to measure a few parts of a couple of parallelograms and see what we notice, because if we can find a pattern, patterns almost always lead to theorems. And let's see. So I'm going to take this ruler and I'm going to measure a side. And it looks like this side here is about 8 1/4. Yeah, a little over 8. So let's try it over here. What about this side? How does it compare? Huh, it's the same. Well, that's interesting. So once I know that 2 sides are the same, that makes me feel like, well, are they all the same? Is this one going to be 8 something? No, it's not, actually. It's like something. It's hard to see this ruler. But let's move it over and see what we got over here. Well, it's the same. That's interesting. So it looks to me like 2 sides, the parallel sides have the same length. So one set of parallel sides has a length, and they are congruent, and the other set has a length, and they are congruent. All right, well, that's interesting. Let's come on, little ruler. This isn't as fun as I thought, because I can't get this little electronic ruler to move. Oh, there we go. Get out of here. Okay, so what about this one? about 6. Let's check its opposite side, its parallel side. Also 6. That's interesting. And what if we turn it, whoops, gotta go this way to measure these other guys. This one is, I don't know, about 2.5. And this one is about 2. Uh-oh. Oh, there we go. Line it up right this way. Yeah, about 2.5 as well. So this big parallelogram on the left and the smaller one on top, on the right, have the same properties. Let's check the last one, just to be sure. We're going to measure one side. 5.5. Measure the other side. 5.5. Yep, and it looks like this parallelogram is going to confirm our suspicions. A little over 5. Also a little over 5. Okay, so it appears by just, throwing some parallelograms up here, and let's make sure we know this one is a parallelogram because it is. What we found in every single one of these cases is that this side, let's do this in a different color, this side is congruent to this side, and this side was congruent to this side. And we found that here as well. The opposite sides had the same length. And this one, same thing happened. So that's interesting. Now let's take a look at angles. Do you have an idea about what we might be able to say about angles? Just wondering. So let's look at some angles. And let's see, this angle here is about 140 degrees. See that? How 0 here, 110, sorry. 0 down here, and then if you measure it all the way up here, it's about 70 degrees. Wow, Miss Waite. 70 degrees right there. And then let's flip it around and measure the opposite. So here's the 0 edge, and we get to 70 again. Well, that's interesting. So it appears that these opposite angles are congruent. Well, let's try this on another parallelogram, a different shaped one, see if we get the same thing. So here's our 0 edge, and we got to go all the way around over here to 140 for that angle. What about its opposite? Will it be 140? Let's see. Let's line it up. Here's our 0 all the way out here, and if we look at this side, it definitely seems like it's 140 degrees as well. So opposite angles are congruent in this one as well. One more to check. Let's see, 0, and this line goes all the way out here. So just a little less than 110, so probably 108 or so. Let's flip it around and see if we get the opposite angle the same. All the way around here. Oh, well, will you look at that, 108. So in all three of these parallelograms, and we only measured one set of angles, we found that this angle was congruent to this angle. We found this angle was congruent to that one. And we found that this one was congruent to that one. And that was true in every single case, which is kind of cool. And just so you know, the other angles would be congruent as well. And this is the thing that's neat about parallelograms. The second you have a quadrilateral that has two sets of parallel sides, you have a couple of theorems. And these theorems say if a quadrilateral is a parallelogram, then the opposite sides are congruent. What this means is the second you know that an object is a parallelogram, you know everything about the sides. You know one side, you know the other. That's how this goes. And the same thing we saw in the little kind of investigation we did was that the opposite angles are going to be congruent as well. And again, we start with if a quadrilateral is a parallelogram, then the opposite angles are congruent. So you can tell a lot about a figure the second you know it's a parallelogram. This parallel kind of thing locks down those sides, locks down those angles, makes sure that things are congruent to one another. So knowing these two pieces of information, we can start solving problems. Did I skip something? Nope. Alrighty. So it says to find the values of x and y, and so these are two different problems. Notice that, let's just tackle the x one first. So we'll find x. That's going to be the first part. So we have x showing up in a little algebraic expression that is indicating the measure of the side AB. We also notice that side DC opposite that is 12. And furthermore, we notice, very importantly, that this object, this quadrilateral, is a parallelogram. So if a quadrilateral is a parallelogram, then opposite sides are congruent. In other words, x plus 4 has to equal 12, because opposite sides in a parallelogram are congruent. So all we have to do is subtract 4 from both sides to find out what x is. These cancel, and x equals 8. Done. Now for the second part, finding y, we have the other theorem, because now we're talking about angles. If a quadrilateral is a parallelogram, then opposite angles are congruent. So y would have to be equal to 65. And we've already solved this one. There's nothing else to do. You can use these formulas, or sorry, these theorems to tell you the lengths of sides. Second, you have a parallelogram, the opposite sides are congruent, and also opposite angles are congruent. A couple more. Number one, find FG and the measure of G. So FG, let's see, what do we, this is just take the first part of this. Let's call it, gosh, Miss Wait, learn how to write. Part A, how about that? FG. Well, let's see. First of all, I have to recognize that it's a quadrilateral. It's got 4 sides. Then I have to go, okay, so in this quadrilateral, opposite sides are parallel, making it a parallelogram. Now in a parallelogram, opposite sides are congruent. And so FG, the one that I'm trying to find, this one, is opposite HE, which we know is 8. And so FG must equal 8. And then part B, find the measure of G. Well, if a quadrilateral is a parallelogram, then opposite angles are congruent. And G, this angle here, is opposite E, which measures 60 degrees. And so the measure of angle G must also be 60 degrees. And we're done. Number 2 is a lot like the last one, and it is a lot like this problem here and this problem here kind of squished together. So part A is to find the value of x. So let's do that. Notice where our x is. It is opposite this 50. And in a quadrilateral that is a parallelogram, opposite angles are congruent. And so 2x must equal 50, because those opposite angles are congruent. And then we just divide by 2 on both sides and find out that x is 25. Part B is finding y. When a quadrilateral is a parallelogram, opposite sides are congruent. And so what we know is that y plus 3 must equal 18. Subtracting 3 from both sides gets us our answer. These cancel. Y equals 15. So using this theorem to set up these little equations, knowing that in a parallelogram, opposite sides are congruent and opposite angles are congruent is really helpful. And that's it. Kind of a short little video today. We could have done more, but sometimes when we talk about too many theorems at once, it gets confusing. So that's enough for now. We're going to take this in 4 parts. Your first practice about parallelograms is on Big Ideas Math. It's called Parallelogram Theorems 1. Gosh, I hope you have a great day. Let me know how I can be helpful. Bye.